In this video, we're going to talk about some spur gear terminology and some of the principles involved in designing gears. So first of all, there are four circles. When you talk about spur gears, there are four very important circles. The addendum circle, which is the circle that passes out at the tips of the teeth on the top land up here. The dedendum circle, which passes through the bottom land. Those are two real circles. In other words, you could actually physically measure them. Then there's two imaginary circles that you can't see on the gear. One is the pitch circle, and the other is the base circle. Right? The base circle is important because it's used to generate the involute profile, the involute curve profile that's used to create the gear tooth. The pitch circle is very important because the gears will behave as if they were drums, friction drums, with diameters equal to the diameter of the pitch circles. In other words, if you just had drums with diameters equal to the pitch circle and some friction between them, and the ratio of the pitch diameters was 2:1, then the smaller drum would have to rotate twice for every one time the larger drum rotated. So another thing we want to talk about is, here's another picture right here. And I should mention that this chapter is provided courtesy of Jack Zhu, professor at Drexel University. So we can see we have the addendum circle up at the top land, the dedendum circle down here at the bottom land. We have the pitch circle, excuse me, and the base circle isn't shown in this diagram. And the addendum is the distance from the pitch circle out to the addendum circle. The dedendum is the distance from the pitch circle down to the dedendum circle. Now, the dedendum always needs to be larger than the addendum so that you don't have any jamming of the teeth here. And the difference between the dedendum and the addendum gives you the clearance. So in other words, if the top of the other tooth was down here, it would be at the pitch circle plus its addendum, and you have to have some clearance down here. Another important point is that for the gear we're going to make, that at the pitch circle, the tooth thickness, this circular thickness, is going to be equal to the width between the teeth. If you go further out, the width is larger than the thickness of the teeth. And if you go further down, then the width is smaller than the thickness of the teeth. Another very important parameter in spur gears is the diametral pitch. Now, in the past, we've talked about the pitch of a screw or bolt and what that means, chain pitch and what that means. Well, this is something different. The diametral pitch is defined as the number of teeth per inch of diameter. Okay, number of teeth per inch of diameter. So for instance, if you had a diametral pitch of 20, that would be 20 teeth per inch of diameter. So a 2-inch diameter gear then would have 40 teeth. And it can be shown that this circular width of the tooth right here is just going to be equal to pi divided by 2p, okay, where p is the diametral pitch. All right, and that could be easily calculated because the number of sectors you would have here, right? If you have, for instance, a 20-tooth gear, you'd have to have 20 spaces, and you can calculate the circumference of the pitch circle. Just divide that by 4 spaces. That would give you that circular thickness by, I think I said 440. So anyways, that thickness turns out to be pi divided by 2p. Okay, so let's go back up here. And the next thing we want to talk about is something called conjugate gear tooth action. So conjugate action is the ability of the gear, as said here, to transmit the motion in a constant angular velocity ratio at all times. This is somewhat counterintuitive, and actually I'm going to have to stop the video here, and I'll pick this up in the next video.